While giving lectures on classical mechanics, my favorite thing to do is to ask the class to explain the second law of motion. Almost immediately I get the response. F equals ma. Nope, incorrect. F equals ma cos theta? Ooh, fancy. Still not correct though. Hang on. What is the third law of motion? Every action has an equal and opposite reaction? Yeah. What about the first law of motion? An object continues its state of rest or of uniform motion unless acted upon by an external force. Also correct. You happen to remember both the first and the third laws of motion as statements that explain certain physical events happening in this world. And you happen to understand them fairly well. Now when it comes to the second law, you know it as F equals ma but have no clue what it means in the physical world. You don't know how and where to put this law in the real world. That's alright, you can learn it now. Here is an equivalent statement for the second law of motion. Force is the time rate of change of momentum. Along with the conservation laws and the universal law of gravitation, the three laws of motion paints an elegant picture of this deterministic world. We call it the classical mechanics. The trick to master this discipline is to view the laws as not just individual building blocks but also as the glue that binds together all the other building blocks in the system. Here is an example. Let's take a look at this video of the renowned martial artist Bruce Lee. This is a video of him demonstrating his famous 1-inch punch. Let's see how we can use the laws of motion to explain what is happening here. From the first law, we already know that in order to move an object that is at rest, an external force has to be applied. In this example, it is the punch that Bruce Lee delivers which provides this external force. But this law, the law of inertia, does not say anything about the force, like the nature of the force or the magnitude of this force. The law of inertia just introduces the term external force. But what if you are interested in knowing more about this force? Da-da-da-da! The second law of motion. Here is the thing. Momentum can be defined as the quantity of motion contained in a body. Loosely, it's like the money you have in your pocket. You see, this money in a way defines your purchasing power. Similarly, the momentum is a number that describes the amount of motion contained in a body. So, in our example, Bruce Lee's fist traveling towards this gentleman has a number associated with it. We call it the momentum. Upon collision, just like transferring money from one account to another, the punch delivers a certain quantity of momentum from Bruce Lee to the gentleman who is getting punched. Suppose point A had 10 units of momentum and upon collision it transfers 8 units to point B. Point B gets 8 units of momentum while point A is left with just 2 units. Now point B has to move because it just received 8 units of momentum, and if you remember, this number corresponds to the quantity of motion contained in the body. It means the object has to move. In our example, Bruce Lee's hand immediately comes to a halt, indicating that he has transferred all the momentum to the person through the punch. So Bruce Lee's fist has 0 momentum left. It comes to a halt, obviously. There you go, the second law of motion.